Hello everyone, can you hear me? Great. So should we start? Shashant, can you hear me? And Nakul? All right. All right, then I'm starting. Hey, Abhinav, are you also able to hear me? Good, good. All right, so everybody in. So last time we were talking about the architecture of. All right, All right, so I think we talked about. All right. So last time we talked about the general SQL syntax. Yeah, you can ask Abhinav. So Abhinav's question is that in a circumstance when your key contains spaces, we cannot join, right? So in these cases, basically all it means is you need to have something of the sort, you have to do for each and generate. Okay, so that's how you clean the data. So pig is essentially used for the whole ETL. So you will do before, if you want to clean up your data, say each key is having spaces or something of that sort, you would use for each statement, and then you will generate something like after trimming the strings. Okay, after trimming the strings, and then join. Yeah. So there will be one more step in which you will just iterate over the whole data set and apply trimming on each of the value and put it in the output. And then you join the newly generated relation or data set. All right. Okay. So do one thing, just put it on the forum. I'll reply with an example and how exactly you could do that. All right. I'll reply on the forum. Yeah. So pig Latin trim. So there is a trim function, I remember. Yeah, there is a string trim function, you can see. So you can use this function, Abhinav, for your cleaning up. All right. Also, a better way would be to use something like a regex, a replace, where you say replace old character with a new character, or you could do something like a regex extract. Okay. So regex extract, what it would do is you take a field, okay, you take a field on which you apply the regex match, and then you apply the group. Okay, so if you want to extract 192 out of it, what you do is you let it match, or say you want to extract the host out of it. Okay, so you match this with this regular expression, and this will be captured in the first group, and you put 1 here, you will get the IP. All right, so you could use the regex extract, and it's quite good. Sounds good. So probably you can use more generically, you could use regex extract, which is quite better than using any replace or anything, and more generic actually. All right, moving on. So I think we were on this slide last time in the last session. Okay, so there are two kinds of tables. One is managed table and external tables. The only difference between the two tables is when you drop a table, if it's managed, then the data, underlying data gets deleted. If you drop an external table, the underlying data doesn't get deleted. It remains there, right? And just let me turn off my phone. Okay, so that's the main difference between a managed table and external table is. So whenever we say create table, it creates a table, as in it creates the metadata, and then it also creates the underlying file. But it basically make a note of where to create the file. Okay, and as a understanding, whenever you are creating a table in Hive, okay, so the data goes into HDFS and the metadata goes into MySQL. All right. So whenever we are saying create my table and these are the things we want, in those cases, I mean, the metadata is, you know, stored onto my MySQL. So I'll show you. Let me just log on to our server. All right. So I'll show you later. Let me just finish completing describing things. And we have not started the record. Okay, we have started the recording. All right. So, okay. So Hive Meta Store is the basically the storage of the metadata. Whenever we are creating a table, like in this case, when we said create a table called employees, Did we discuss all of this? I think we discussed. Yeah, yeah. Or do I remember it from the past session, my previous session? Okay. So if we did not do, then I think let's just start from the beginning. Okay, 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 okay. So that means, okay, in simple words, all right. So should I start from the very beginning of Hive session? All right. So everybody wants to start from the beginning. All right. No worries. No worries. Okay. So Pig is great and MapReduce is great, but there are a lot of people who are very comfortable with SQL. So few people, few developers, they thought that if they could convert an SQL query into MapReduce, it will be great. And that's what they did. And that's what is known as Hive. The problem with Hive, problem with the way it has been is that metadata support is a difficult thing. Okay. So let me try to explain this. So there are a lot of people who are not very comfortable with the development, not very comfortable with the programming, a programming language, but they are very comfortable with SQL. Probably 90% of the people who works in software development company are comfortable with SQL, but only few percent of people are actually developers. All right. So that's the reason why Hive as of now exists. So whenever do we write a query using Hive, it basically gets converted into maps and reduces and then gets executed on the uh, as map on the Hadoop. Now the way we have Pig is basically a client. Pig does not have a server in the back end, but this one has a server in the back end. All right. So Hive is great in the sense that whenever you write a query, it gives you the output. Your standard SQL knowledge works here. The only downside of it is that you cannot make inserts and update as of version 0.12. In future, the insert and update is also coming in Hive. Okay. So they are trying very hard to make Hive write the data to HDFS. So far, it was just an analytics tool, and nobody actually used it for updating the data. So those were the limitations. It did not provide you the record level insert and update and delete, and it was comparatively slower because for two reasons. First, any query you write, it has to be converted into Hadoop MapReduce, and then those MapReduces need to be executed onto the MapReduce framework, which means there is going to be a latency. Okay, going to be a warm up time. There's going to be 10 to 12 seconds of delay between you enter the data and you get the results. All right. So therefore, it is not suitable for real time computing or online transaction processing. It's not suitable for. And this is the general architecture of Hive. Okay, you have Hadoop as usual, then you have a driver. The driver is the one which takes a query, converts it to MapReduce and get it executed here, and driver communicates with metastore in order to understand the definitions of tables. and driver is being used from the command line, and then Hive web interface, then thrift server, and JDBC and ODBC, right? Other than that, there are multiple other clients. The way we have Hue, our web interface, which basically calls uh, a Hive web interface, and similarly there's Qbol, Karma Sphere, and whatnot. There are many kind of web interfaces or interfaces that makes it. Okay, Amit has got a good question. Let me try to answer it. In case if there is a reporting system, would it be advisable to have two systems, one for one for recent history where people see very often in some relational DB, and other one using Hadoop and Hive? Okay, so basically people generally keep two kinds of things in place. If you have a look at Google Analytics, for example, Google Analytics gives you two kinds of analytics. One is real time analytics, and other is something which is 1 day old or 6 hours old. Okay, and that's a pretty much norm. So if your system is very high throughput and lot of data is coming in, and you have a lot of data being accumulated in HDFS or Hadoop, a better smarter thing would be let there be a scheduled job, and that scheduled job basically creates the data, pushes that data onto a relational database, and your web application keeps on displaying the reports from the relational database. Okay, so that is the general norm, and that is how lots of people do the job. Okay, and for giving the real time kind of a view is requires a completely different kind of architecture altogether. You need to have a system which can basically operate in memory and retain most recent data in the memory, and that you give it to the end user back. Okay, and most of the real time systems, they generally give out comparatively smaller data. All right. All right. So the pipeline for you would be that I'll show the pipeline what Amit is asking. So say imagine that you have Apache web fleet, okay, having say 20 web servers. From them, the data is being pushed to HDFS. Okay, and this push could be due to, Apache web server fleet, and the logs are being pushed using say Flume. Okay, and it is going over here. All right, now, so on one hand there is Apache servers which are pushing the logs to your HDFS. On another hand, you want to display say number of visitors with number of visitors who from number of visitors from mobile. Okay, so there are two ways to compute it. mobile devices, okay, and number of visitors from mobile devices in last 1 week. Okay, so what will you do is you will have your maps and reduces. Okay, maps or and reduces, or maybe you have your pig queries to convert the unstructured data, cleaning it up, or pig, or maybe hive or map reduce, whatever you want to do. Okay, convert it into structured data. Okay, they generates a tables of the statistics. Okay, and this table, the next step would be, okay, so this is our objective is this, and then using the pig query we are converting into tables. Okay, either hive table or maybe CSV files. Then using scoop we move this table to MySQL. Okay. Now in MySQL you have everything, these statistics upfront prepared, and every now and then and once you create all of this flow, you schedule everything using Uzi, and afterwards you can comfortably run all these scripts. Okay, and your data will be available in MySQL from where you can cater to your web application. Sounds good to you? So was I able to give answer to? Okay. So MySQL will be storing the data in its own storage. Okay, it will not be storing in HDFS, and that is mostly the small data. Now imagine this number of visitors per device. These are just numbers, so it is going to be very small data. Maybe say 200 rows and two columns. Okay, two columns. One column is name of the device, and other column is the counts. That's all. Okay, so this can serve it really good. And sometimes what you do is you also maybe not really date time, maybe last updated date time you can keep. All right. Okay. uh, okay, Ranjit, no problem. So I was just describing what do you do in case of an architecture where you have lot of data in HDFS. So Ranjit just joined, so let me just summarize in 2 minutes. So how do you generally build a system to in the real life? So imagine that you have to prepare number of visitors from various mobile devices in last 1 week. I mean, number of visitors who visited your website, and imagine that your website is a high throughput service, meaning there are lots of people who are visiting your website, and the logs are being prepared on say 20 servers. Okay. Now, in these scenarios, what you do is you push all of the logs using Flume into HDFS, and after that, or maybe some other mechanism, after that, you will run your pig queries, or maybe Hive, maybe MapReduce, to generate the tables and CSV, and you push it into your MySQL, and from there the web application will push it to the end user. So these are the various steps. And the way you tie all of these 5 6 things together is using Uzi kind of workflow, step by step. And in Uzi you will say that run this thing every 6 hours. Okay, and every 6 hours it will keep on executing these scripts to do various kinds of things. All right, maybe between scoop and mysql here you might have to delete a table first and then move, and between here you might have to do few more things. So all of that can be done by using a OG kind of server. All right, great. So here we were describing the general architecture of Hive. Hive is basically something which takes an SQL query and generates the MapReduce. So other than a converter, which is the driver which compiles the query, optimizes, and then executes it on Hadoop, there's something called metastore. Metastore is where the information about the table is being stored. Okay. Because whenever you do a query on the data, if you have metadata, you need to keep it somewhere. And other thing is, unlike pig, in pig, whenever you created a relation or a data set, whenever you said a equals load something, okay, if you disconnect the session and come back again, this data set does not exist. Okay. But in Hive, when you create a view, create a table, it persists. It remains there forever. Okay. So, and that is why a meta store is required. All right. That's what the meta store is used for. Now, moving on. So this is the word count example which we have done earlier also in SQL. Okay, it's not very much useful, but it just tells you that using a single query you can do the word count again. Here the most important one is this line, which splits the line by space, and then after it has converted a string into array of words, it uses a syntax called explode, such that a array of values is converted into a multiple rows. So if there is a sentence containing 15 words, it will result this will result in 15 words, 15 rows. Okay. After that you group by and do the counting. So afterward, everything else is simple. You just group by the word and count it. You have already done it earlier. Okay. Here the important part is you first move the file onto the HDFS. After that, you you use this syntax. Okay, where you say you create a table called docs. Okay, create a table called docs using this. But here, important part is that you have already defined a table. The definition is not available here. Okay, okay. So you can start using Hive right away by SSHing into our Hadoop 1, Hadoop 2, Hadoop 3, or Hadoop 4, anyone. And you can run Hive either by simply typing Hive, or if you want to execute a particular command, you can use Hive minus E and then command name. And if you have got a list of commands, a list of command is basically called if you put all the a list of commands into file and save it, we call it a script. If you want to execute a script, Hive script, you can use it hive minus f and then script name. Okay, and this is how your general looks like. The creation of table, create table x, and we say, and let me start the Hive, create a table called x, and there is a column called A with the data type int, and then you can say select star from A and drop table X. All right. Now, the other DFS commands you can execute like ls or maybe move, put, all of those commands you can run from inside Hive, just like pig. And also, if you want to load a Hive script from inside the command prompt, you can use this kind of syntax. Okay. So we can say something of this sort. Okay. And then we can say select star from X, although there's no data, so you won't get a data. And you can say drop table X. So all those people who are from SQL background, they must be feeling very happy after looking at this, and that's exactly the purpose of Hive. All right. So queries are synchronous, unlike Pig. Mm, as in, as soon as you click on execution, okay, okay, got your point. So whenever we say A equals to load, it immediately exits, it immediately comes out rather than actually loading the data, right? That's not the case here. Whenever you do something, it actually does exactly what SQL used to do, except for the cases where you want to create a view. When you want to create a view, things don't happen right away. They happen at a later point of time whenever you do a select star from view. All right. Now, so stop me if you are getting any doubts anywhere. All right. And the comment is general standard SQL kind of comment. You put double dashes and it's a comment. You can see that it's a comment. Oh, select star from X. Let me see what happens. Interesting. And if I say, so if I did, okay. All right. So how do we load data from source to start working with Hive command? Just give me a second and I'll be there. All right. You can use variables like this. You can define a variable and then you can use them, and you can execute shell commands like this. All right. So if you say exclamation, it runs the command locally. If you say dfs minus ls, it runs the command on the HDFS. Okay. All right. So these are the data types. Standard SQL data type: tiny int, small int, big int, float, double, decimal. And the awkward part with Hive is that they started with a simple data type like Java, but but lots of people from lots of background ha- are using Hive. Therefore, they had to include more and more data types every day. Say for although they do the same thing, for example, timestamp and date, they do both the same thing. Similarly, binary and boolean, they do the same thing. And varchar and char, they do the same thing. So just to accommodate various kinds of SQL queries of various databases, Hive has accommodated all of these kind of a new database, new data types. So after 0.13 version, the char was included, and after 0.12 version, the varchar was included. I mean, from basically starting with 0.12, starting with 0.13. So more importantly, most of these data types are very well supported by by Hive. Now, other than our usual data types, there are these data types which were generally found in databases like Postgres, the complex data types, where each column could be an array or each column could be a map of arrays and so on. So, because when we deal with structured data or unstructured data, we might have a complex data type such as a JSON format, and that need to be mapped to one thing or the another. All right. So, therefore, the complex data types are required. So, an array is basically something like 1 comma 2 comma 3 comma something else, and you define in this array all the data, all the values have to be of the same data type. You have to define that data types. It's not optional. You have to define all the data types properly. Map is a key value pair, a collection of key value pairs, and the key is always a primitive data types, while value is any kind of data type. While struct is just like your structure or a class or an object. If you're coming from a JavaScript background, you can think of it like an object. And if you're coming from uh, Java background, you can say that this is a class definition. And in case you're coming from a C background, it's a struct. Okay. And then there's something called union. Union basically allocates only one of the all values. So at one time, we can define like five, I mean many data types, but only one of those values will be there at one time. Okay. Say for example, authentication type or authentication ID. One system might be using long, other might be using a string, and but we have only one column or one field to accommodate that. Okay, so that is union type. Exactly how the union in C works. All right. So here Facebook ID, Google ID, email ID, either of these three things could be there. One is string, other is int, or other could be, big varchar of 200 and so on. Okay. But it will store only one of these at a time. Now, to manage the data, like in our class, you have many people and they are working on their own stuff and they might be having different permissioning tomorrow. But but you all can work together in your own databases. You define your own database or it's like your namespace, and you can start working on that. Okay. So you can say create database, my database, and then you can start working on that. Okay. And if you want to display the current database which you're using, you can use this. Okay. Now I'm using the default database. If I say show databases, so there are so many databases. If I say use as Giri, so you can see this thing. And if you want to drop the database, you can drop the database. And these are the standard syntax. And if exist is similar to what you do in MS SQL or Oracle. It doesn't throw error. Okay. So here you can say show tables, which shows you all the tables which Sandeep Giri has created, like this. Okay. You have employees, you have these tables, all right? And you can start select from one of the tables, and you can say limit 3, all right? So this way you can immediately have a lookup in the table. Afterwards, you can have a look at what's going in with one table, understanding what are the columns in that table. Okay, so it shows you that these are the columns and these are the data types of each of the column, right? If you want more details, you can say formatted, and it will show you a lot and lot of details about the table. It shows you what are the data types. It shows you who is the owner of the database, when was it created, when was the last access time, and where is it physically located. So you can see that this is where it is actually located. Okay. So if you go into Hadoop 1 and say, not this, we say a file browser, and yes, you can copy the tables from one database to another, or you can also do select star from one table into another. So okay, so your question was if I can copy the table from one database to another. This I need to think about. Maybe you can do something like select asgiri.nysc daily, select star from this. Okay, and then you can do insert into some other table using this. Okay, so the syntax is database dot table name, and that you can use. All right, now what I was talking about, the data is located onto this place, you can see here. So as you can see, the data is in the same format what we had. Okay, and how do we make this? Okay, it's screen blindness. All right, so moving on. So as I was telling you, whenever we are saying create table, there are two kinds of tables we can create. One is the manage table, the normal table. Whenever we say create my table, blah this, and there is another way called right. Just hold on a second, don't worry. And then there is something called external table where we say create external table. The only difference between the two is in case you drop a managed table, the data gets deleted. In case you drop an external table, the data remains wherever it was. Okay, so you can think of this way. In Hive, the table is like a view on top of a data which exists in HDFS or some other place. Unlike our usual database, we insert the data into a table, and then it always stores it its own way. While here we load the data into Hive, we tell that this is how you are going to interpret it, and this data might exist in HDFS, it might exist somewhere else, and and so basically there are multiple ways Hive can store the data. Okay, so let's move on. So whenever you do not own the data, you go for external table. If you own the data, then you go for managed table. But mostly since Hive as well as Pig both are used like an analytics tool on top of the data, they never are used to create a set of table, edit the data. Therefore, it is always advisable to start with external table, and the tables you external table as in there is some already data lying on HDFS. We create an external table on top of this data and start representing as a table the same data. So I generally prefer external tables, because in case I drop my external table, it won't impact the data on which I've created this table. In case I created managed table on top of an existing data, then whenever I drop a managed table, the data gets deleted. So performance advantage is not much. There's no performance advantage because internally the semantics are same. Okay. So as I was telling you, every time you create a database, create a table, add columns, or you define that it's an external table, internal table, all of this information needs to be persisted. That persistence happens in the Hive metastore. And for Hive metastore, it generally on MySQL, and this MySQL generally runs on one of the computers. Okay. Why? Because the load on retrieval of the metadata is not too much, so we can afford to have a single machine running MySQL. So Susan's question is, in both the cases where the data is stored physically on HDFS, so in case of managed table, the data is generally on HDFS. The data could also be in the HBase, all right? But in case of external table, the data could be at places like AWS S3, and the data could be anywhere. Okay. So the metadata is stored into a database running locally on one of the machines, and it contains what the name of the database is, the name of the tables, table definitions, columns, partitions, etc. It can be Derby, it can be MySQL, it could be any database which supports JDBC. I'm answering Ranjit Sahu's question. All right, so let's start with something. So if you have something like this table where you define create my table with these columns, and here the important part is we define here how is our data going to get stored physically. It says that row formatted, delimited by delimit fields, row formatted, delimited fields, and terminated by slash t. And similarly, we could have delimited rows by slash n. So, whenever the data gets inserted into this table, it is going to get stored in this location, okay, on HDFS, and the data is going to be tab separated. Okay, so let's create a table. Let me drop table NYSE daily. Okay, now I'm creating it again at the same location. All right, so the table has been created. Okay, which means the metadata has been added into the. Let me log in it once more. SSH student. So the table has been created, which means metadata has been created. But physically physically nothing has happened as of now. If I click on this, this folder is empty. Okay, the folder is empty. So for each table, a folder is created. Okay, for each table, a folder is created in which the data will be stored. Now the next thing is loading the data. You can load the data using something like this. Here I am saying load the data from local, from this location, and overwrite the data of this table. You can see the syntax, right? Load data, and this is small, but it doesn't matter generally. Okay, so you can see that data got copied from this file to HDFS first. This is my local file. Okay, so this is my local file. You can see that on local file system it does exist. Okay, so home asciri under hive you have asciri slash hive, and you have this table nyc daily. So I'm saying load my local file into this table called NYSE daily. Now the moment I do it, the data at this folder will be created. Let me refresh the page. So here all I'm assuming is that you know SQL. It's just that I'm trying to make you understand how are you going to deal with Hive and how are you going to use Hive for querying. Okay, so you can see that this is created and the data is tab separated. Okay, so I think I have answered your question, Swati. And in case of .txt file, is a direct load possible? That's what we did, right? Here, it's basically a text file. No, I did not get your question. So here also, we did the direct load over here. Okay, word count problem. Then explode command was there, yes. In that, you are talking about probably probably here, like this, right? So I think it is possible, but I don't know really. I don't know. I doubt that. You have to create the table before you do that. Let's just do this, okay? We say here, and we basically try to do something of this sort. Okay, it got loaded again. So it says table not found. All right. So it says table not found, which means you need to create the table first. Which means that my slide. Okay. So If we do not, if you see, let me answer Swati's question. We have this New York daily, and we say select star, select count star from NYSE daily, right? Okay. So basically, if you do not overwrite, more rows will be added into the same file, same table instead of overwriting. Abhinav's question is, can we have concept of SQL constraint also in Hive? No. Unfortunately, no. Okay. So it doesn't provide you the syntax for creating primary key, foreign keys, and all of that as of today. But people are working on it. So yes, in our case, it's not required, but the objective was to give you a demonstration of what does it mean by. All right. Now, so all right. So whenever we are, there are a few more things you need to know about. So whenever you are loading data from local, the data gets copied, which means your local copy is of the data stays. In case you are moving data, you are doing a copy, basically you are loading data from HDFS, the file moves. Okay, so keep that in mind before you load the data. Either you make a copy of your data, or you are fine with moving of file. Okay, so there is no way to stop moving of the file. So load will move the file. Load will actually move this file NYSE daily into the place of NYSE daily. Okay, it'll basically put this file also a- as one of the files under that folder. Okay, the data folder, this will take this file and move it there. Okay, so keep that in mind. That is one difference between loading from local and loading from HDFS. This has been done in order to make the system faster, because whenever you are creating Hive views and all of this, you are basically trying to use an existing data. Okay, and existing data is generally pretty big. Therefore, as a design decision, load basically moves the data uh, on HDFS in case you are doing um, load from the HDFS. Okay, so hope that clarifies it. Also, by default, it expects the fields to be separated by Control A and will create the directory for the partition, if any. Then, okay. So whenever you are loading the data, in case you have not defined in your table structure that this is the format you expect, it will expect it to be separated by Control A. Okay, and all right, and we'll create the directory for the partition, if any, while you are loading the data, and then copy the data or move the data in case of HDFS. And if and also a Table could be partitioned or unpartitioned. We'll talk about this later, so we can skip this part right now. All right. Now we have created a nice table now. Just now we said select NYSE daily and limit it to say 50. Select star. Okay. All right. Now doing things we when if you're comfortable with SQL is quite simple if you see. So so Sushant, are you able to log in into this command prompt? I have not tried from you, but I have been trying to fix a couple of things with respect to Hive. So I'm hoping that it would be working, but I need to yeah, I need to check that. In Pig, in case we didn't define the data types for each column, it still works. That won't be a that won't be possible with Hive. Yes, that is one big difference with Hive and Pig. And that's so because in case of Pig, it does handle any kind of data type. Later, lazy data type direction or early, it handles it neatly. But in case of Hive, that's not possible. Okay. So now you can start doing something like, you know, symbol, then you can say average, and what is that data type? Symbol, and then exchange, let's say price open. Okay. Price open from this group by symbol. All right. So it'll do the basic sanity check on the fields which we are doing. So I'm trying to compute the average open price of a symbol, and we can do a lot of things using SQL query. Okay. All right. So we have been able to do the querying. All right. So it has started doing map reduces and it is done with the work. So you can see the average price of each symbol. You can say select distinct symbol from NY. See, daily. Okay. So this will give you the distinct symbol list from NYSE daily. Okay. So what is so big deal here? Uh, the big deal is that we will be able to churn hundreds of terabytes of data easily using our SQL query. Okay. So that is the big deal in this. All right. So hope that makes you happy. And now the data is, if you don't define the data location for your tables, it will by default create the data in apps hive warehouse on HDFS. You can have a look at this location. And as a matter of fact, since all the applications try to store their data onto HDFS, they generally put in this folder. Okay, in apps like HBase is also storing data, Hive is also storing data here, Tej is also storing. Tej is one of the components, and then all of them are storing the data onto HDFS itself. So here you can see that for each table, if you don't define the location of the data, it creates over here. Okay, it creates a folder for each one. So somebody has moved the data from for word count. Okay, and here is the whole file. If you can actually edit the file, refresh the file, and all of that. Alright. So either it gets stored here or it gets stored in the location definition, right? The way we have defined location here, or by default it will be created there. All right. So that makes sense to you? Now, if you want to take the data out of Hive, you can do something of this sort. You can say insert, instead of load, we are saying insert override local directory and select star from here. And you can see that you can take out the data like this. So it will come to a folder called tail minus f, and I say tmp and only cmc. It is yet to come. All right. Now, if you want to take out some portion of the data and put it in another file, you can do it this way. All right. If you want to put local over here, the file will get created on HDFS. Now you can see the data has been created. Okay. By default, it has put Control A between the fields. You can put something else, and you can see Control A. Now let's talk about partitions. So as you saw that whenever we are pushing data, we are basically putting, you know, creating a huge table, or there may be hundreds of tables. But there is no concept of just looking at a data window. If you want to just look at one section, can we some way optimize that part? All right. So in I mean, indexes are not possible in these kind of data sets. So something be done? So therefore, the partitions were created to avoid the full table scan, and you will basically be creating the partial file scan. Okay. Instead of doing a full file scan, you will be doing partial file scan. Meaning one table is stored in say 20 files based on some criteria, and whenever you are looking for that criteria, only a particular file is accessed. Let's say we created a partition on a particular column, say name. So for every distinct name, we had these different files. And whenever we are loading data from this folder, whenever looking for the data in this table, For a particular column value, only a particular file will get accessed instead of the whole file scan. So data is stored in different files based on various combination of values of columns. So if you have three columns and you want to say for 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 first January store the data in this, for second January store in this, for third January store in this, and those are partitions. Okay, all right. So let's have a look at what does a partition look like. Here it is. So say you have a file called the employee and you have a table called employees, and in this there is something called qualification on which you are trying to create the partitions. Okay, now every time you say basically this is the definition of employees table which has one, two, and three columns implicit, and one more column which is defined by partition column. Okay, so effectively there will be four columns. Every time you do select star from this table, you will get this column as well in the output. Okay, so let's say we have this and we define a table called employees. Select star from employees, I think it is already there. Drop table employees. So we created a table which has name, salary, and degree, and fourth one is the qualification. Okay, and we have just okay. Now when we say describe, it tells you clearly that it's a managed table and it's a partition table. You can see that partition information. The column name and data type is here called qualification. Okay, and after that you can basically, so the table is not yet created. So when we say from this is, and do we have another table called cat the emp one? Yeah, so these are the two files we have. We are loading the data from these files into this table, and now you have a single table select star from employees having all these columns. Okay, although it is actually storing the data at two different places. You can see that. So you can see in this folder apps hive warehouse employees, that's where it is going to store the data. It contains two folders. Okay, one is qualification equals to 1, other is qualification equals to 2. So whenever we are going to put this as where clause saying where qualification equals to 1, only the first folder is going to get scanned. All right, so we can also say show partition employees and I'll show you the partitions. All right, so basically we are creating these partitions manually. All right, hive doesn't do it for you. You will have to do it by yourself. Okay, and also note that the partitions can be from different locations. Okay, going back, you can have multiple partitions from multiple places. One set of data is lying in HDFS, other set of data is lying in EC3, EC2, meaning AWS, in S3 buckets. And uh, so basically that's the benefit of having these partitions, specifically with external table. All right. Also, you can later on add or delete a partition or add or delete a column just like usual table. You can to rename a table, you can simply rename the table. You can change the column names, and you can alter the data types of columns, as well as you can add more columns. Okay. Also, you can add more partition. So there is not much of a cost over here. So Abhinav's question is, what will be the cost of adding later partitions? Yeah, so there'll be not much of a cost because it's not doing anything. It's just marking that there is one more partition and that's where the data is. All right. So here is one partition, okay, which we can drop. We are basically dropping a partition. All right. So okay. Now to Swati's question. So so we can have Hive running on EMR to read. Not really. Even if your Hive is running on our Cloud Labs, it can read the data from S3. Okay. So when you deal with really humongous data, say there is a public data set published by Amazon, which is 500 terabyte, and what you want is you want only one section of one particular file. Okay. So you can define your table as a external table on top of that particular data. Okay. On particular file from the Amazon's cloud itself. And then when you are doing churning, it will be reading data directly from EC2 instead of storing it locally. Okay. Although it is arguable that whether which one is beneficial, but it is definitely possible to read the data from third party services directly. Now Abhinav's question is, but it will have to move data from main to, no, it will not move the party data. That's what I was saying. You will have to create these partitions manually. It doesn't divide the data. It doesn't do anything at all. And that is why when you define a partition table, you don't define the column like a usual column. Okay, which means that whenever people are inserting data into this table, they cannot insert this qualification value directly. They have to define a way of partition. All right. So okay, so what happens when you do the partitioning? As- I mean, I would talk a little bit about, okay, I think this is covered at the later section also. Okay. Okay. So there is something called bucketing also, which has been recently introduced. If you want to, instead of you yourself creating these separate files, you want Hive to create different buckets so that while churning the data, I mean only specific buckets are called. Okay. So you generally, while you define your buckets, you generally define it this way: cluster by user ID and sort by view time, and do it into 32 buckets. So this will store, basically, when people are adding data into page view, it is going to divide it by user ID and store at various in various buckets. So this is something, an alternative to indexing, what Hive people have done. Okay. So this is also one way of doing creating indexes on top of a file system. Okay. But as you see that there are only limited set of buckets. Yeah. You can't, I mean, you can't create, there is a limitation number of buckets. All right. Now there is something called external tables, as I told you, that you can define an external table on top of existing data, or using a syntax called external. There's not much of a difference between managed table and external. The only difference lies in the fact that when you drop this table, nothing happens to the actual data. Okay. So you can see, yeah, I was able to create immediately the external table on top of my data. Yeah, it's a kind of it, but it drops the metadata. It drops the metadata because this table is going to persist. Okay. Persist as in, every time you connect to this server and you say show tables and select star from this table, it is going to give you the results. So that data, that metadata, is going to get dropped when you drop this table. Now, the another benefit of an external table is you can create an external table from outside. Say your data is lying on S3, okay, and you want to read the data into this particular, you want to create a table on top of some data lying somewhere else, say on S3. So you can create that using this kind of syntax. This will not copy the data locally, it'll just create a kind of a view on top of that data, and then you can start saying select star from many wiki stats and do this, do that. Okay. And in case this data also contains folders and is already partitioned by some means, you can say that this is a partition data and these are the partitions. Okay. So mini wiki stats would, you can create external table which is partitioned, and and point it to an external data lying somewhere on S3 or somewhere, and so that you don't have to copy the whole set of data. All right. So example of the same thing what I have been discussing is you created a table, say log messages, and partition it by year, month, and day, and then delimit your fields by a tab. So this is your definition of your table. Once you have created your external table, also note that when you create an external table which is partitioned, or when you create a partition table, you don't have to define a location for it. Okay, you don't have to define a location because external partition is going, we are going to anyway add the partitions to it. Now at a later point of time, we are saying alter my table and then add a partition called this one with this location. Okay, with this location. So For whenever a query for year equals to 2012, month equals to 1, and day equals to 2 is coming, then we will be looking at this location. Okay. For another section, whenever people are whenever people are looking for, whenever people are putting this clause in the where part of the query, this part where year equals 2011, month equals to 12, then it'll read it from h3. Okay, but when you say select star from log messages, it is going to scan all the partitions, and it might take maybe 12. If your data is lying on all of these places and it is in a terabyte size, it might take couple of days based on your bandwidth. Okay, if you are saying select star from log messages. All right. So generally what happens is when your data is lying at multiple places and you want to represent it at a single place, then you generally have these kind of partitions. Okay, so Ati's question is, suppose we do operation on this external data, where exactly does the processing happen? Okay, so in very simple words, processing is going to happen on your own MapReduce. It is not going to get delegated to S3. It's more like a view, as you say. It's more like a view. It's going to read data from there, bring it locally, then do the computation. All right. So that is external partition. Okay. So let me summarize what we have just discussed. Each table has got a location. By default, the table is a directory under apps hive warehouse. You can override that location by mentioning location in your create table syntax. And load data copies the data if it is local. Load data moves the data if data is on HDFS. Dropping managed table does not drops the data. If you are dropping a managed table, it deletes the data. If you drop an external table, nothing happens to the data. The metadata is stored on the relational database. Okay, in Hive metastore. Okay, all right. So select statements are pretty straightforward. So anybody has questions with respect to select statement? So to check the metadata, first you can simply say describe formatted and NYSE daily. Okay. While if you are, so right now the way we have configured from our admin interface is that it should be storing the data in my MySQL and into this database. So this is where it's actually storing the metastore. So there are all sorts of tables it has created and putting the information over there. Okay, you can see that there is something called tables, select star from tables. You can see there are so many columns lying over there. I had created NYSE daily. You can see this, and there is something called employees which is being created, and then tweets SBI which I was working on earlier. So these are all being created into the into this hive. Okay, into MySQL. All right. So that was, I was showing you MySQL, the metadata store. Basically, if you had to design something of that sort, you will have something, a table called tables, in which you will put all the details about all the tables which users are creating, and so on. So Sushant's question is, so from the terminal, we do not have to register the table at Edge catalog. Load takes care of this. Yeah. So Edge catalog is basically a metadata service, and on which basically people use Hive as a service via Edge catalog. Okay. People use Hive as a service via something called Edge catalog, and to store various kinds of metadata, various kinds of, basically the layer which was created for Hive to read the data from various places was abstracted out, and they created something called Edge catalog so that everybody can use this data service. All right. Now that is okay. Moving on. Now, anybody has any questions on this? So these are standard SQL statement. Select name from employees, and you can also give a name to the table. So well, H catalogs the facility of not providing. Not really, not really. You have to define the data types. I doubt if it does. Okay. Okay. Maybe I need to look into H catalog a little more. Okay. So as per my understanding, most of the definition of data need to do with H catalog. Anyway, I will discuss H catalog later by time. Okay. All right. Let me make a note of it. So also we can, as we all, so who is not acquainted with SQL? Okay. Let me ask the other way. Is this particular row make sense to you? Anyone else? Yeah. And what about a little complex one? This one. The computation on the column, select upper name, comma salary, comma deductions, and then I'm saying federal taxes, and out of that I'm saying round. I'm calling a function called round and multiplying salary into deductions minus. So so basically, the way we were doing projections like for each and generate in SQL queries, we do it this way. Okay, this is a function which we are calling on top of one column. This is select upper, and then column name. This is this is a hash table, as I was in one of the examples when I was talking about complex data types. This is a hash table, and when I say this, it's basically loading the particular value of this key, and then I am able to form a complete complex expression as part of select statement. Now, aggregations we all know as part of query. We say select a comma aggregation field, and then field name, aggregation on field name, and so on. Okay. At a lot of places, what does it mean by, at a lot of places some aggregation can be done in the map phase itself. For example, the count star or count something can happen in the map side itself. Okay. So you don't have to sort the data for doing these kind of operations. So if you set this variable as true, then some of the computation can become faster because Hive will start detecting that what are the things it can do on the map side itself. So for count star, if you have to do count star, you don't have to really run sorting. You don't have to really do a kind of a reduce. All you have to do is just scan this file and return the number of records. Okay. So some of the aggregations could be done on the map side itself. If you want to enable that, it will make a process little faster. Now, there is something called views when we talk about SQL. Okay, and these views are very, very helpful. These views are very, very helpful. So you can think of when we say A equals to load something, this was A was essentially a view on your something, and B equals to filter. This was, I'm talking about pig here. Okay, filter A on where by X equals something, right? So B is a view on A and A is a view on something. Effectively, the whole thing is combined. So the moment we say dump B, you get all the things in something after all of these operations. Similarly, in case of SQL, you can create view on a definition of table. So if you want to do it again and again, select something from tweet simple and left outer join on this. So if you want to give it a name as a new table, so that we don't, when we are forming a complex query, the complexity gets divided into multiple views. Okay, so as an example of, so let's have a look at this table. So if you see this table, this query, it's actually around 100 lines long, but because of the views, we created a view here because we started creating views. Okay, one first view we created, then we created another view on top of this first view, then we created another view on top of this view, and we kept on doing it and till the end, so that the whole complexity of the operations got separated into individual units. Okay, so there was a, say we downloaded data from Twitter, we want to clean it. We wrote a query to clean it up, we give it a name, and then from that we selected few fields and so on. So exactly what pig did by creating each individual operations, views are exactly for the same purpose. Okay, all right. So if you want to create your custom functions, if there is one function, so like the way we had these nice functions over here, like upper round, in case you want to create your own function, you can do that by exactly same mechanism as we did for pig. You create a class, called lower, and then you whatever class you want to create, and then you create a function under that. So every any function you want to create, you will have to create a full class for that. Okay, you have to create a full class for a particular function. And so here you say this my class, it extends UDF. Okay, it basically inherits all the features of UDF, and it has a function called evaluate, to which we will be passing text, and after that it will be returning a text. Okay, so when we say lower, lower is going to take a text and convert it to lowercase, right? Therefore the return type is text and input type is text. Now once you're finished with that, you create a jar of it, add the jar, this your dot jar, whichever you created here, your dot jar, you basically load that jar into Hive, and then you can start using that function. You define a function like this, okay, that my lower function is this, and then you can start using that function wherever you want. Okay, you can load this function like this, like this. All right, so you can try it just the way we did for pig. You can also try it for Hive. And just note that you just have to copy from your local machine to the server, and then you have to add jar. Okay, and also a more detailed example is available over here. Okay, you can have a look at that. You can create the reader writers. So all right, let's take a break of 10 minutes and back by. All right. All right, so I'm here. No worries, Sushant. Okay. All right, so should we start? All right, so sometimes when your input is in a very different format, it's not, say, comma separated, tab separated, or usual field separated, it's not there, then you might have to use a different kind of serializer, deserializer. Okay. So when you have different kind of serializer, you generally use your when creating a table, you generally say that my row format is this. All right, and that way you essentially are able to store the data in different format as well as read data from a different format from usual separators. Say for example, if you have to use JSON data, how many of you who doesn't know JSON? What is JSON? Who doesn't know the JSON? Okay, okay. So basically, JSON is a JavaScript object notation. So when you take a JavaScript object and you want to send it across the wire, meaning from your browser to the server, you can represent the data, any object, in form of simple string. And that string will look like this. So if you have an object, it will be inside curly braces. If there is a field inside the object and it has got some value, then it will be like this. Okay. And similarly, if there is a field, uh, another field, let's say here, my name is Sandeep, and courses is, say, MongoDB and Hadoop. So this is an array representation. Okay. So basically, it's a very, very simplistic file format for a complex object types. Okay. So CSV, you can represent any data which is of tabular format as well as tab separated format. You represent your tabular data in those formats. But if your data is complex, okay, data is like your big complex object, in those cases you generally use a format like JSON to represent your data. JSON or XML. XML is awkwardly bulky. Per field it consumes equal to the, it basically, on an average, XML is twice bulkier as compared to JSON format. So that is JSON. So if your data is in JSON format and you want to load that into your database table, and remember that since Hive supports complex data type, it is easily possible to load any complex data type data. Okay. And therefore it is possible to load any kind of JSON format into the database table. And for that, there are many libraries. One of this particular library which we use is most popular out of all. And to use these kind of library, you can, the way I described, how do you add a jar? You open prompt and say add jar and say my dot jar like this. Okay, and this will load. Okay, add jar, or we can say add jar my udf dot jar. So I don't have the something. All right. So never mind. And then you can mention that this is the particular class we want to use to load the data. And as a part of the project, you will be using this here. So our data is from Twitter, and this is the complex data type we have defined here. And we'll be loading this table from a JSON data using this particular Serde. Serde means SERD means serializer, deserializer. So the definition of how data is getting converted into file is defined as part of serializer. How the data is getting converted from file into a table is defined as deserializer, and both of these things are defined as part of this jar. All right. Now that is what we call it serializer, deserializer. So whenever you have to handle JSON kind of data, you can use this this particular library. All right, and there are many similar we call them. So we, if we have to say XML, Serde, Hive. Okay, so there is this XML Serde, which is also quite popular. You can use this one. Okay, and you can basically download the data and start using that. All right. So the important part about sorting is earlier the sorting was very inefficient in Hive. Whenever we said order by something, it was inefficient. It was basically pushing the data through one reducer, through a single reducer. Okay, which makes it impossible to use for the huge data sets. And basically at the end of it you have a huge file containing all of the data in ordered format. Now, so people started working on it, and they ended up with cluster by X. So it started by order by X, was the simplest form. Then there was something called sort by X. Parallelly, using n reducers, the data is sorted, and each reducer can receive overlapping ranges of data, and you end up with n or more sorted files with overlapping range. So this was okay that we were able to divide the work, but a better strategy was to distribute as well. As if you do distribute by X, this will ensure all the reducers get non-overlapping ranges. Okay, okay. So first you have to distribute and then sort. So instead of using this syntax again and again, they everybody started using cluster by X. Okay, so whenever you are trying to sort the data in Hive and the data is humongous, then prefer cluster by over order by. It is as simple as that. Okay, you should prefer cluster by instead of order by when you are dealing with humongous data. All right. So let me give you a quick demo although we have already given you some demo, I think. Okay. So there is not much about this demo. I think you should do it by yourself. So first we create a table called u underscore data 8 November with these columns. Row format is given, and along with that we download this file. I have already downloaded this file. Okay, and where is it located? Not here. Yeah, it is located in asgiri folder. It is located in asgiri folder. You can use that file. So wget basically downloads any website. If you want to recursively download any website, you can use wget. And so this will basically download movie lens data. The significance of this store as text file is you can store, when you are creating files, you can store in many number of formats. Okay. So here text file, this is actually by default. You don't have to specify it explicitly. Okay. So text file as in plain text file, it will be stored as plain text file. You can also define something like RC file, and other kind of files. But RC file is good for Hadoop, HDFS kind of Hadoop kind of when you have to do a lot of operation in form of Hadoop in MapReduce, then RC file is better. But let's ignore that part for the time being. Yeah. So this will be stored in text file, yes, in HDFS. That's correct. So you create this table, okay? Then and before that you create your own database, okay? Create your own database, create your own table. You don't need to download this data. If you want to download, you can download it. There's not much of an issue. These are basically movie lens rating. Who who rated which movie, how much is what you get from here, okay? On what date? That's what you will get in this from this u.data under this. Okay. Now you load this data u.data into this table and then do various kinds of analytics on top of it. Okay. You do various kinds of analytics such as for each movie, how many users voted it up? Total number of users, how many users were there who voted for each movie? For movies having more than 30 ratings, what is the average rating? All give me the average rating for only the movies whose rating is more than 30. Okay, so that's the sort of exercise for Hive. Okay, that's a sort of exercise for Hive. Is it clear? Is the problem statement clear? All right, so try doing this. This will give you a good amount of confidence in Hive and will give you a comfort factor also. All right, so that's pretty much about Hive. Okay, now let me. All right, should we start with HBase now? It's basically NoSQL plus HBase today. All right, so why do you want to read NoSQL? So that if you have no expertise in SQL, you can still write in resume. That's the biggest benefit of learning NoSQL. All right. So okay. So when you are dealing with a larger database which spreads across multiple systems, when you have a lot of load, you have to spread the data as well as the load as well as the computation across the cluster, right? So the first portion of any database which is supposed to handle a lot of load is that it should be able to divide the data across the whole cluster, right? So when it is dividing the data across the whole cluster, it is supposed to be giving you it should be able to track which row is where, which means each row or each document and each entity has to have some sort of identification. So almost all the databases, these new generation databases, which were designed basically for scalability. Most of these databases were designed basically for scalability. Long back, on one Christmas, when Amazon could not handle the load, they had a very bad Christmas that time, because on Christmas they get maximum request, and when they could not handle it, they decided to they decided to do a lot of things in order to scale their servers. So first thing they did was they bought lot of hardware. Second is they realized that the Oracle, they actually used Oracle for everything, pretty much everything. And as of today also, they use Oracle for a lot of things. The catalog is still in Oracle. Now they're moving. Now they realize that for a lot of works, Oracle is the bottleneck. And that's when they sat down, and then one of the engineers said, let's just have a most simple database called key value pairs, which should spread across the network. And that database was known as the database was known as your I forgot the name. How can I forget the name? Dynamo. So that database was known as Dynamo, and afterwards a lot of people worked on it, and lot of in the beginning it was just plain text key and plain text value. Later on they moved it to binary key and binary value, and in which you can store any object and everything. So basically a NoSQL database is a database, new generation database, designed for scalability in the mind and distributed computing in the mind, and hence it is supposed to have an ID for each record or document. It is it is generally open source. Why? Because if it is not open source, nobody is going to adopt it. Every These are horizontally scalable, distributed, horizontal scalable, and manage use data, they are all synonymous to each other. And the only problem is when these kind of systems come into place, they cannot handle the relational structure mostly. Okay. So there are more than 150 in the market as of today, right? All right. So why NoSQL? In simple words, to handle the load, to handle the big data, and to have a scale out architecture. Availability and big volume and scale out, as in today we know that we have few users, but we know that we are ready for tomorrow also when we have thousands of users. We can just add more hardware and everything will keep on scaling up. So one is handling big data, meaning you have terabytes of data as of today and you want to push that into a database. And second is high availability. High availability means that that no matter what we'll be able to cater to the users. That is high availability. And scale out is if we will keep on increasing hardware as we go forward. So that is basically the objective of using NoSQL. Now, NoSQLs are generally categorized into four broad buckets. First one is column oriented or wide column, as in they look like most of the column oriented or wide column, they look more or less like traditional databases. They are closest to the traditional database with a little bit differences, such as generally NoSQLs don't have a rigid schema. They don't enforce rigid schema. And second is the document oriented database. Document oriented database is something which basically have a humongous document as a, instead of row. Okay. In a table, you have a row. Row is a list of values. In a document oriented database, each of the table or each of the collection is made up of the complex objects in the form of XML or in the form of JSON or in the form of other formats. Okay. And you can look up for based on various attributes. So if you had to store say tv shows contains many seasons contains episodes, and episodes contain reviews as well as has many cast members. So if you form a JSON objects out of it and store it, a document oriented data store is better. Okay. The example of the HBase which we are going to discuss today is a column oriented database. In column oriented database, the only difference from the traditional one is the data is going to store internally column wise. We'll give an example, don't worry. And then we have key value pairs. Key value pairs are the most primitive and the beginners in the game. They are more or less like a big hash table. Okay. And a graph database is good when you want to store a complex structure of objects, where so a document is generally in the form of tree, while a graph is connected in multiple ways. If you have to traverse a Facebook friends graph or similar, then a graph database will be more useful to you. So in this, the one which is not yet mentioned is, okay. So there is a database called Giraffe as well as Neo4j. These two are most popular as compared to the other ones. Alright. This is a simple, straightforward comparison. So relational databases were invented in 70s while NoSQL came in 2000s. Types, all of the relational database are follow the same philosophy, while NoSQL databases are of many different. And NoSQL is basically basically a Twitter handle of the few guys who were going to attend a seminar on new generation databases. So they created that handle and that became quite popular. So that's how the name came into play. There are many examples of NoSQLs, and there are hundreds of databases as of today. The biggest difference is with respect to the data storage model. All of the SQL databases, they follow the relational database. They follow the same chords principle, but NoSQLs don't. Okay. The only common phenomena across all these NoSQLs is that they are built for scalability. They're built for scalability and they don't support acid properties properly. Almost every NoSQLs, almost all NoSQLs are not able to provide you acid properties. I'll describe you why. Okay. So you have there is a valid reason why none of the SQLs, none of the NoSQLs is able to provide you the the kind of acid properties you expect from RDMS, and there are reasons, and the reason is in the form of a theorem called cap theorem. Cap theorem says that out of three things, consistency, availability, and partition tolerance, out of these three things, you can at most you can at most support two. You can never any database, none of these databases can give you all the three things. So Amit, I did not get the question. Graph does support acid property? Alright, so let me again iterate. Not really. They might be providing consistency, but none of them will provide acid property. Okay. So out of these three things, consistency means all the users, all the clients will see exactly same data at the same time. Okay. Also, consistency also means that if A user came and wrote a data and after a millisecond B user comes in, if if that B user is coming after A to access the same data which A wrote, then B should always get the the data which A wrote. So that is strong consistency. That is the definition of consistency. Availability is that your system is available to the end user. There is a guarantee that every request is answered. Okay, even if it fails or successful, but every request goes, none of the request goes unanswered. That is the meaning of availability. And then there is something called partition tolerance. Partition tolerance means in if your network gets partitioned, or in case one of your machines go down, one of the machines got shut down, in that case your system don't get impacted at all. Okay, you everything runs as usual, even if one machine goes down in your network. So that is called partition tolerance. If your network get partitioned, still it it is able to respond to the user's request. Everything works as usual. Okay, so these are the three things. Out of these three things, none of the databases can give more than two. So either a database can be consistent as well as available, or can be available and partition tolerant, and it can be consistent and partition tolerant but not available. And this diagram shows you that. So MongoDB is not consistent, it is partition tolerant and available. So if node equals to 1, then it's not really partition tolerant. Because if that node shuts down, that means your system is no longer able to give the response, right? All right. So out of this, you can see consistency and partition tolerance. The here big table, hypertable, HBase, MongoDB, Redis, and Memcached is consistent and partition tolerant. But this is wrong actually. This is actually wrong. MongoDB doesn't lie here. MongoDB lies over this side. Partition tolerant and availability. These are almost, while HBase is strongly consistent. So if one node goes down, it should not impact any of the end user. That is what means the consistent. So you keep your backup such that no single node can impact your data. All right. So this diagram is actually wrong. Let me make a note. While MongoDB is lying this side, okay, and Cassandra is also this side. Cassandra is actually tunable, and HBase is this side, strongly consistent. Okay. So most of the database exist in either this or this, but almost everyone almost everyone is going for this one now. People are avoiding the consistency because that is the one big problem. Now, why is it so? I think this diagram will make it clear. Now, imagine this. So, if you have a single machine and there are two users which are trying to read and write to it, okay? So, both of them will go to this database and then try to read or write from it. While one is writing the same row, the other one will wait in the queue till first one finishes, and so on. And because of this kind of queuing, when people are one another user is waiting for first one to finish, we say that our system is not properly available to both. Okay, and therefore we cannot say this system as available. Okay, and in case this machine goes down, that means none of these users will be catered. That means that this system is not partition tolerant. The system is not partition tolerant, because if one system is going down and its users are not able to access it, that means it's I mean it's not partition tolerant, but it is strongly consistent, because if one user is writing, another user is immediately coming after him, he will get the fresh data. Now, in the second diagram, you have got two machines. All the users write to A, and all the users who are readers, they read from B. Okay, so when a user writes to A, the data gets transferred over the network, goes to B, and then users read from it. Now, i- if these users are coming just with the 1 millisecond difference, if this user on the right hand side is coming after 1 millisecond, before 1 millisecond, then the reader will still get older data. Reason being that there is a delay in between between the data being available to the reader and the data being written. So because it takes time to travel for the data to travel from A to B and synchronization. Therefore, even though the writer came before the writer came before the reader, writing the same data, the reader will still see the older data. If they try to make it 100% available, okay, as in 100% consistent, then both reader and writer will have to read from A and write to A. So this diagram shows that providing this kind of architecture is not consistent. This is eventually consistent. In long run, everything is going to settle down properly, because all the writers are coming to A, which means there is no inconsistency while writing the data. It's just that it's taking a little bit of time. So eventually it's going to get consistent. But right now, all the readers are going to read. All the readers are going to read an older set of data. So this diagram is inconsistent. Okay. So here in the third diagram, this architecture is essentially kind of a backup model. All the readers and writers are writing to A copy is being maintained on B. So this is consistent because readers and writers are coming to only a single machine. But and also partition tolerance, in case A goes down, readers and writers will be reading from B. If in case B goes down, they will be happily doing reading it from A. The flow doesn't get interrupted. But it's not available. Reason being, here the queuing will happen, and the more queuing will happen, A will not be able to handle the load. Okay. Therefore, these three diagrams essentially show you that it's not possible to provide all the three things: consistency, availability, and partition tolerant. Cap theorem is this is what cap theorem says. All right. Now, let me take you through a case study of what used to happen before distributed databases came into play, before NoSQL. So you launched your product, initial public launch, you moved your data from your private workstation to the server and did a great party and launched it. Now service became popular, as in some people posted it on say slash dot, some people posted it on TechCrunch, and your service became popular. You did a computation of say 20 users per second, and you did a testing, but suddenly you realize that more than 1000 users are hitting your server per second. So and all the service is basically hitting the database again and again. So what you did was you put a caching mechanism in place called, say memcached. Memcached is a distributed cache. You placed a memcached on your website so that website doesn't hit the database again and again. Those pages which are pre-computed are given to memcached, so the recomputation doesn't happen for quite some time. Now, if you realize, the moment you bring in a cache, bring in a distributed cache system like memcached, you are no longer acid compliant, right? So the moment you bring in cache, because there is a difference between the time it takes to refresh the cache and and the data is being written. Okay. So the moment, all right, after some time, still your server is slow. So what you did was you beefed up your machines, you put up more hardware, you put up more hard disk, you put up, not hard disk, you put up a better CPU, more RAM, and instead of slow hard disk, you brought in really fast ones, or maybe you put solid state hard drives. At that time, the solid state hard drives were not popular, and now it goes pretty good for some more time. So you did a vertical scale up, and you're pretty happy. It's just that you have burnt few crores to buy few systems, and are pretty happy for few days. And then new features request keep on coming from product managers, and developers start building those, start shipping them. More and more tables are being added, more and more tables are being added, and to serve to user search, you are doing say 100 joins at a time. And that point you realize that it's the complexity which is eating you, and immediately immediately what you do is you start the process of denormalizing. So where the joins are happening quite often, you start copying the data into the same table, start forming a single table out of instead of having separate tables. Now the DBA gets a heart attack looking at the denormalization process, because DBAs are taught not to do the denormalization. And okay, so first you sacrificed the acid properties. Second, you sacrificed the normalization. Now, still, still, after a while, your system will further get slow. There are because there are you stop doing some things like the computational server side, as in you stop doing stored procedures, and still the queries are slow. So what you do is you start pre-materializing stuff, meaning you start doing pre-computation. You know the behavior of users, so you start doing pre-computation and start preparing things upfront before the user is requesting for any data. Okay. Okay. So you sacrifice joins by denormalizing the data. You sacrificed your acid properties, and you have already sacrificed the 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 liveliness of the day, the another level of consistency by doing a pre-computation, and still the writes are getting slower and slower. Reason being, there are indexes. Now you stop dropping the indexes, and that's where you realize that everything a database has to offer, you have rejected all the things. You effectively rejected everything, such as indexes, from your table in favor of the performance and availability. Okay, and this is a typical story lots of companies went through, and anybody went through this cycle actually survived. The people who did not evolve, who did not do all of these things, they could not survive. Okay, so those people who were really active and who struggled really well to cope up with the load, they survived to some extent. Okay, because after that people realized that they need to move away from databases when it comes to a humongous load. Okay, so they started having moving lots of portion of the data onto static side, and a lot of things were done. So this is a typical story of any e-commerce company or any widely popular companies. Okay, now before I move on to HBase, so we talked about cap theorem, we talked about the typical story of a highly available service. Now let's talk about something called column oriented database. A column oriented database is, from the user perspective, it is same. It's just that while storing, the data is stored column wise first instead of row wise. Okay, in our typical database table. Yes, Abhinav's point is that can't we use clusters like MySQL cluster to solve scaling problem? Yes, you can use cluster, and probably on in many websites as of today, MySQL is still used is being used as on the cluster. And how do they use it is by the way of manual sharding. Sharding as in you slice the table into pieces, okay? And you define one primary key on each of these tables, and there is a router somewhere which figures out near the load balancer, which figures out where should a query go. Okay, if it's from, if the request is coming from India, it goes to one server. If request is coming from uh, US, it goes to another MySQL database, and so on. Okay, so if you think about it, such kind of MySQL will again be inconsistent anyway. Exactly, the joins will be very hard, in fact. All right, so people do that, and they effectively are using MySQLs in the form of NoSQLs. And all the sharding as in dividing the data as well as dividing the traffic is their manual intervention. Okay. Also, high availability is their own problem. They have to build the high availability by themselves. That is why a NoSQL is better when it comes to the high scalability, because you will have to do a lot of engineering to make MySQL work for a high load situation. Okay, so I was describing you what is column oriented database. A column oriented database, the storage looks like this. Okay, so let's say there is a table, employee ID and employee name. So the way it is going to get stored is, in a typical row oriented, first you will store the row ID, say 1, and then employee ID, then employee name, and then again next one, next row, and then next row. But in case of column oriented database, you will be storing first column first and then second column. So 10, 12, 11, and then Joe, Mary, and Kathy. That's how you are going to store. All right. So this is what we call as column oriented database. Now, HBase, which we are going to discuss today, is a column family oriented database, which means we group the columns into something called column family, and column families stay together. Okay, so here employee ID and name are part of column family 1, while age is part of column family 2, and the way it is going to get stored is 10 Joe, 12 Mary, 11 Kathy, and so on. All right, and then it will come as 20, 23, 33, 45. So hope you understand what does it mean by column family oriented database and column oriented database and row oriented database, right? So which one is better? That's a very difficult question to answer. As per lot of people who did a statistics analysis, they found that column oriented database is far better when it comes to higher load. Reason being, reason being, it is easier, it is faster and better to compress this data together, because each column is going to have a similar set of data, so it's easier to compress it. Okay, as in the compression results are far better. Okay, so if this particular, say, a column is being stored in one file, B is being stored in second, C is being stored in third, and you compress A separately, B separately, and C separately, there are high chances the values are repeated, and therefore the compression results will be far better. As per one study by Facebook, they said that column oriented databases have a better compression. Therefore, they came up with a format called RC file. Okay, RC file is basically column oriented structure and great for this kind of situation. Okay, but having said that, HBase has taken a politically correct step that they are column oriented as well as row oriented. If you put all the columns into single family, that means it is a row oriented. If you put each column into a separate family, it becomes column oriented. Okay, so in my opinion, a column family orientedness is far better because you can emulate either of the situation using column family. You can emulate column orientedness as well as row orientedness using column family, right? Okay, so the other reason for a column oriented database in case of distributed computing is that one column would be stored at one place, another will be in another, and so on, right? So, and when you are retrieving the data, you want to hit minimum number of minimum number of machines as possible. Okay, so your tendency is generally to get a subset of you are looking for three columns, but out of these three columns you might be looking for any values at any time. That means any values, as in you put a where clause will have to scan through the data. So the minimum number of servers are included as part of where clause, the it's better. Therefore, if you have column oriented database, the maximum number of servers you will be hitting is those maybe three or maybe six at most. Okay, so as per certain statistics computation, you can figure this out that if the data is divided by columns, you will get you will you will get faster results. Okay, all right, so let's talk about HBase. HBase is a column family oriented database. It makes it possible to emulate column orientedness or row orientedness. It is based on Google's big table paper. Google published a big table that basically they used a big table for storing their corpus from internet. As in all the data they download, the crawler which is downloading the data from various websites stores the data into big table. All the documents they download. It is good only if your data is of size hundreds of millions versus or billions of roses. Hundreds of millions or billions of rows instead of few thousand rows. In case you have few thousand, I think MySQL and these other databases are far better. Even you have, even if you have millions of rows, still your MySQL is better. Okay. So unless and until you have really huge data, don't go for things like HBase. Okay. It is strongly consistent and it's not eventually consistent. MongoDB is eventually consistent. Sharding is automatic, as in, what does it mean by sharding? Sharding means dividing your data into pieces, into sections, just like you divided the files into blocks in case of HDFS. Similarly, sharding means that you are dividing a big database table into set of rows. And a set of rows are basically called regions, and these regions move to various region servers. We'll talk about this in little more detail. So HBase is made up of two kinds of machines. One is called HBase master, and rest are called region servers. Okay. So region servers contain the portions of table, each table, in the form of regions. For churning the data on top of HBase, you have to use Hadoop, and HBase stores the file onto HDFS. Okay. So to churn the data, you can use MapReduce, and or you can use things like Hive. Okay. HBase itself does not provide you any query language. Again, HBase provides you thrift interface, which means you can connect to HBase from any database, any JDBC driver, or any programming language. HBase provides you something called Bloom filters and coprocessors. Coprocessors are similar to stored procedures. When you want to execute things on certain events, such as a table got deleted, a row got modified, then you define coprocessors. And Bloom filters. Bloom filters is a set of algorithms which makes it faster to query the data. Okay. So it doesn't provide you any indexes. It's not something a great thing to do, but you can emulate indexes by yourself. The only index it provides is row key. Every row of the table is has a column called row key, in which all the keys, all the cell values are basically ordered. All the values in a row, in this column called row key, are sorted, and they're physically stored in the same manner, just like your primary key. Automatic partitioning, as in, as your table grows, the table keeps on splitting, and the splitting into the regions, and the regions keeps on moving between region servers. And in case you want to add more machines at later point of time, it is absolutely okay. The regions will automatically start moving to the freshly installed node. So all you do is you add a node, point it to the existing cluster, and start the region server. The regions will automatically balance, and so that this node becomes equally loaded as compared to the existing nodes. So the other characteristics of HBase is that it is built out of commodity hardware just like HDFS or any other system, and it is fault tolerant. Lots of node means, I mean, fault tolerance as in there are many region servers. Even if few region servers go down, there is nothing to worry and there will be no downtime. All right. There is something called batch processing. MapReduce integration allows fully parallel distributed jobs against your data with locality awareness. As in, just like we processed HDFS files using MapReduce jobs, we can also process the tables in the same manner. Okay, which may basic, which effectively means the way we had blocks across the cluster in HDFS, we have regions across the clusters in 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 HBase. Okay, so this is a general architecture of HBase. At the bottom, you have HDFS, and then there is something called Zookeeper. Zookeeper will take it up in the next session. Zookeeper essentially makes sure that coordination between various services is great. Zookeeper is more like a traffic police or a big notice board on which everybody uses for coordination with other people. Okay, so Zookeeper is a service which a generic service. It is not dependent on Hadoop or HDFS or anybody else. Zookeeper is a general service which HBase uses Zookeeper in order to have the communication between region servers and HBase master. So HBase is built, HBase has something called a master, which basically is the one which knows which row is where, which region is on which machine. The master node, just like name node and data nodes, master knows where is the reasons. The reason servers contain these these values. Okay, region servers are basically bunch of machines which on which the reason as in section of rows are stored in the form of h file. The h file is the one which is basically the representation of the table in the file format. Okay, and then HBase provides API to the end users. All right, so I think we should take up the data model because this is very important. Probably the most important part of learning the HBase is understanding how can you create the data model. Okay, how can you how can you convert your problem into HBase data model. So let's take it up tomorrow. All right. Okay. So are you there or you have gone to sleep? All right. So we will take it up. We'll take up the data model tomorrow and go through the Hive session. Yes, you have only Hive assignment for today. All right. Okay, Nakul. Okay, Ranjit, Abhinav. Thank you, Seema. Thank you, Swati. Thank you, Julie. Bye, Megha. Thank you. Bye, Bindu. Thank you, Bindu. See you tomorrow, Amit, and have a good day. Good day.